All right. So we get asked the question a lot, what fuse to run in your circuit. So today Jake's working on his boat, so we're gonna go over a little bit about the way we do it. And it's actually very simple. You can use a multimeter. We use this clamp style. That just makes it super easy. And what we'll do is we go through every circuit, and on the boat there's not a lot. There's a little bilge pump, there's a fuel pump, there's a little vent motor a blower motor to vent out this engine area, and then a few items on the dash, some lighting. So what we do is we're going to go around to every single one of those pieces of electronics, and we're going to run an amp draw test, an amp test on that circuit, and see what it comes out on the multimeter, and then we go up from there. So for instance, if we test something out and it's 3 amps, then we'll put a 5 amp fuse in for that circuit. There's some things to remember, and that is that we're testing it directly at the device that's being run, right at the load. So we're going to check for peak, like startup amperage, and then what it takes to run it. We're going to take notes on all those things. The way I select the fuse is off of the peak amperage. So like a fan motor tends to have a higher amperage at startup and then a lower amperage for running. So if it starts up, it takes 8 amps to start it, then only 3 amps to run it. Well, I don't want to put in a 5 amp fuse. I need to put in a 10 amp fuse because I need to be ready for the startup amperage. The other thing to consider is how far away is that load from its power source. We have a battery laying in here that we're testing directly to, so we're right at the device. But if you're going to be running 40 feet of cable somewhere, then you need to take that into consideration as well as any switches or things that you might have in line. You can do a few things, like right now we don't have any of those wires run, but we just use a cheat sheet chart that tells us how many amperage is lost in a 16 gauge piece of wire for X amount of feet, and we'll add that to our notes later. We can also test the amperage loss in the switch that we're going to use. So we'll just end up doing all the math, and at the end we'll add it up and we'll pick the appropriate fuse. You could also just wire the whole system in and check it after it's all done and do it that way. We're just doing it one step at a time because we have everything available and accessible right now. We'll have Jake do it, so I'll move the camera over here and let you guys see how we test it. All right, so Jake's hooking up this little blower motor. We just have some alligators, and again, like I said, these are going to show a loss because amperage will happen right there. But it's so minimal for what we're doing that we're going to not worry about it too much. So we just use this amp clamp.
We'll zero it out once we get it on the actual wire, so something like that. We'll zero it.
And
so now
you'll connect it and the fan will turn on. So 5 amps. Do it again, let's see if we can see a peak.
I think I saw 9 in there.
Try it again. So now we're hooked up to this little fuel pump over here, and we're going to see what it comes out at. Let's see that peak again. So 2 amps, pretty low amperage. All right, so what we saw was the fuel pump running a couple of amps and the fan running, what was it, 5?
That one was 8 to 5.
8 to 5, so 8 startup, 5 running. It's really hard to see with the amp clamp, the peak startup. But that's what we'll do it. So just for a rule of thumb, if it was 8, then we'll run a 10 amp fuse in that circuit. But we've still got to do all the math, right? We've still got to add in the switch, and we've still got to add in the wire that's going to that fan. The other thing to remember is that when something is under load, for instance, the fuel pump was running just shy of 2 amps. It'll be different when fuel's flowing through it and it's under load. It'll also be different when it's sitting underneath a manifold and maybe it's getting hot, right? Everything can cause amperage increase, connectors, air temperature, everything. So we want to plan for those things. So this is, again, just the preliminary set of tests that we do. And then as we go through the project, we keep getting more and more data, and then in the end, the last thing we do is plug a fuse into the circuit. So this is just all to help us in the end get to where we need to be, which is correctly protecting the circuit.
Some of these things too, because we're not going to be running relays on every single part, right? It's just going to be certain items.
Right. So again, people ask, when do I run a relay? And I know there's videos out there like crazy on this. So you want to switch something on and off. If your switch can handle the load, say for instance we wanted a switch to turn the fuel pump on, we need a switch that can handle at least 2 amps. So maybe we get a switch that can handle 5 amps. That's easy to do. When you start getting into loads that are a lot more, maybe giant fans for your radiator in your car that has a 28 or almost 30 amp peak startup, then you can get a giant 30 amp switch if you want, but some people don't want that. So what you would do is you get a small switch and you would trigger a relay, and the relay would actually be the switch that's carrying the load to the fan from the battery. The other time you would use relays is if you don't want an actual toggle to turn something on. You want something like a temperature sensor to turn your fan on. The temperature sensor will ground out, trigger the relay, and then it'll carry the load to the fan. And then there's also the mindset that people don't want any load traveling through their switches at all. So they want a relay for everything, regardless of the amperage. Sometimes that's nice because then we can do what we call like a ground trigger toggle, and all the toggles on the dash can just be little ground switches. And if I apply the switch, it sends ground to the relay, and then the relay turns the load on, and then we don't have to run a bunch of power cables all the way up into the dash and then back. We can keep all that stuff localized in the back and limit how we're traveling that power throughout the vehicle or the boat. So that's just a quick nutshell. There's a lot to it, but that'll at least help you get started on what size fuse to use.